All right, good morning, ladies and gentlemen. Today we are going to do lesson 7.4, working more with proportional parts, but now rather than triangles and similar figures, we're just going to be working with parallel lines, cutting different segments or lines into proportional parts. But before we do that, just a real quick review, I guess, or a question to add in. We were talking about those similar triangles a lot in section 3, and we were working about similar triangles, but last semester we did congruent triangles. And my question is, if two triangles are congruent, does that mean they are also similar? And if they are, what would the scale factor be? Well, let's think about it for a second. We had, for similarity, we had an angle-angle similarity, saying if two angles in one triangle are congruent to two angles in another triangle, then they have to be similar. If we have congruent triangles, will they have two pairs of congruent angles? And the answer is yes. So if triangles are congruent, they do have to be similar. But what is the scale factor going to be? Remember, to find the scale factor, we did the ratio of the side lengths of one triangle to the other triangle, and then we reduce that ratio down. Well, for congruent triangles, the side lengths have to be the same. So if one side was, let's say, 10, the corresponding side in the other one, if they're congruent, would have to be the exact same thing, or 10. So that scale factor for congruent triangles is always 1-to-1. So if triangles are congruent, they are also similar, and the scale factor would be 1-to-1. That was just kind of a little bit of review, a little extra before we start in. All right, so 7.4, we're going to be talking about a mid-segment of a triangle, but we'll get to that in just a bit. So here we go, starting out, our triangle proportionality theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides, it divides it into proportional lengths. Remember, proportional means that their ratios or fractions are equal. So AB over BC is equal to AE over ED. I like to use that side that's parallel to one side, so this one right here, see it's parallel to that side of the triangle. I like to use that as my fraction bar, is how I think of it. So it's AB over BC and AE over ED, and then you can just cross multiply and solve from there. So right here, it says that RT and VU, this side and this side, are parallel. So here's a parallel line. It tells us SV is 3, VR is 8, UT is 12, and SU is what we're looking for. So again, I'm going to use this side kind of as my fraction bar. So I'm going to do 8 over 3 is equal to 12 over x. Cross multiply, 8x equals 36. Divide both sides by 8. And we do 36 divided by 8. We get 4.5. It asks for SU. SU is labeled x. So we're done. Here again, same type of problem. We have parallel side right here. We're looking for BY, which they label as x. So I'm going to do 4 over 10.5 is equal to 6 over x. 4x equals 60 and 3, 63. Divide both sides by 4, and I get 15.75. That is both x and the side that they ask us for. So, just remember, cross multiplying, use that parallel side as your fraction bar. This is the exact same thing, just going backwards though. This says if we know that AE to EB and CD to DB, if those are proportional, if those ratios are equal, then that's enough to say our lines are parallel. So before it was if they're parallel, these are proportional. The converse, switching it backwards, if they're proportional, then they are parallel. So here we go. It says determine whether they are parallel. So if those are parallel, these lengths have to be proportional. So this length here over this length here has to be equal to this length right here over this length right here. So that tells me DH is 18. HE, it says, is 36. They don't give me numbers for DG and GF, but they do tell me this right here. DG equals half of GH. So I'm just going to make up a number. Let's say DG, which needs to go on top because DH went on top. Let's say DG is 4. I don't know, could be any number. So DG is 4. If DG is 4, 4 is 1/2 of GH. So we can say 4 equals 1/2 of GF. Sorry, 4 equals 1/2 of GF. So to get GF by itself, multiply by 2. So GF is 8, because 4 times 2 is 8. This can be reduced down to 1/2, and this can also be reduced down to 1/2. So our answer is yes. Since it cut it into proportional side lengths, it has to be parallel by that converse that we just talked about on the previous slide. Same idea here. It says XY is 15, YZ is 25, WA is 18, and AZ is 32. Using this as my fraction bar, 18 over 32 is equal to 15 over 25. Either reduce the fractions, or you could cross multiply and see if they work out. I did the last one by simplifying, so let's cross multiply for this one. 18 times 25 gives me 450, and 32 times 15 gives me 480. Since those aren't equal, our answer is no. Again, you could reduce those fractions down as far as you can, and they would not be the same number. So again, you would say no. All right, here's our triangle mid-segment theorem. We worked with a mid-segment theorem of a trapezoid, and this is going to be very similar. So a mid-segment of a triangle is parallel to one side, just like it was with the trapezoid, so it's parallel to that third side. And its length is 1/2, so JK is half of FG. Again, that's the exact same definition, properties, and everything of our mid-segment that we did before. But let's solve some problems. It says DE and EF are both mid-segments of the triangle. So that means FE is the mid-segment and has to be parallel to that side down here. This side is also a mid-segment, and it has to be parallel to that one. But let's find out what they actually ask for. They ask for AB, they ask for this length here. All right, they're asking for a length, and I know that the mid-segment is half as long. So if 5 is half of AB, AB has to be 5 times 2, or 10, because the mid-segment that's parallel to AB has to be half of AB, one of those properties from the previous slide. Here we go. Now they're asking us for FE, the length of this mid-segment. So it's the same idea, just working backwards. We know that this side is 18. The mid-segment has to be half of that. Half of 18 is 9. So FE is 9. Right here, same picture, same information. Now it asks for a measure, though. It asks for the measure of angle AFE. A to F to E is this angle right here. The only other angle I see is this 87 right here. So let's see what we know. We have AB parallel to DE, two parallel lines cut by a transversal. Those are alternate interior angles. So the measure of angle AFE, alternate interior angles, are congruent and therefore have the same measure. So it's also 87 degrees because two parallel lines cut by a transversal, alternate interior angles are congruent. We again have some mid-segments. It wants us to find the measure of AFD. A to F to D is this angle here. Two parallel lines cut by a transversal, alternate interior angles are congruent. All right, so now that idea of parallel lines cutting into proportional pieces doesn't only work for triangles, this works for any two lines. So if for any three or more lines, if three or more parallel lines intersect these two transversals, then they cut them proportionally. So their ratios, remember proportionally means their ratios or fractions are equal. This is only true if those lines are parallel. So right here, we have larch, maple, and nuthatch are all parallel. So we have three parallel lines, and they are cutting this transversal here and this transversal here. So these have to be proportionally to each other. It wants us to find x. Again, I like to use those parallel lines as my fraction bar, so 26 over 13 is equal to, I put this one on top, so x is on top, over 16. And now we cross multiply. 26 times 16 gives me 416 is equal to 13x. Divide both sides by 13, and I get 32. Okay, you also could have set it up as 26 over x equals 13 over 16. That would work just fine. Cross multiply, you end up at the exact same equation here. Another one, we have Davis, Broad, and Main that are parallel, and it wants us to find x. So again, I like to use the parallel lines as my fraction bar, so 24 over 8 is equal to, I put 24 on top, so 15 over x, and cross multiply to solve. 8 times 15 is 120. Divide that by 8, and we, 8 times 15 is 120. We have to divide that by 24. Misspoke for a second. That gives us 5. So our answer is 5. All right. If three or more parallel lines cut off congruent segments on one transversal, it's going to cut off congruent segments on every transversal. So if AB is congruent to BC, these pieces over here have to be congruent to each other as well. This piece is congruent to this piece. Not necessarily all four. The reason why that works is if this is 1 to 1, since they're proportional, this also has to be 1 to 1. So if these are 1 to 1, the congruent thing we talked about at the beginning, 1 to 1, these have to be 1 to 1 as well. So we have parallel lines. These two pieces are congruent, so we can, to find x, since congruent means they're equal, 3x minus 7 equals x plus 5. Subtract your x. 2x minus 7 equals 5. 2x equals 12. X equals 6. I found x. Now to find y as well, if these are congruent, that means these two pieces are also congruent. So we can write 9y minus 2 equals 6y plus 4. Subtract 6y, add 2, and divide. And we have y equals 2. All right. This is the same type of a problem. We can write our equation to 4a minus 5 equals 3a plus 6. That works because they're marked as congruent, so those are equal. Subtract 3a, add 5, and we find that a is 11. So just multiple choice, I could stop there. I know that's the right answer, but if you want to check your work, you could write that 3b equals 5/3 b plus 2. If we do 5 minus 5/3, so we get 3 1/3 b equals 2. 2 divided by that number. So, there we go. And here it is. Last slide is our homework. Pause it here, find it on Canvas, whatever you need to do. Let me know if you have any questions. Please email. Bye-bye.